Hello there. We are discussing geotechnical engineering, index properties, relationships, and tests. Video part 4. Till now, we have seen phase diagrams, fundamental definitions, as well as their relationships and numericals. Let us continue with numericals and then we will go to tests. So, a natural soil deposit has a bulk unit weight of 18.44 kilonewton per meter cube and water content of 5%. Calculate the amount of water required to be added to a cubic meter of soil to raise the water content to 15%. Okay. Assume the void to remain constant. What will be the degree of saturation? So basically we are provided with bulk unit weight 18.44 kilonewton per meter cube as well as W water content initially 5% and water content finally as 15%. So first thing we will do is we'll find dry unit weight from formula gamma D is equal to gamma B upon 1 plus water content. Here we have water content as well as gamma B. So I can find gamma D as 17.56 kilonewton per meter cube. So if I consider 1 meter cube of soil, the weight of dry soil there will be 17.56 kilonewton. It literally means like this. So I'll find WD dry weight as 17.56 kilonewton. To find out the quantity of water required to raise water content from 5% to 15%, I'll find out amount of soil or I'll say weight of dry soil so that I can know the water demand or water requirement. Okay, so finally it was 15% water content. Initially it was 5%. So gap of water content is 10%. 10% of what? So 10% of dry soil. So dry soil weight is already been found out. So it is 17.56. 10% of 17.56 will be 1.756 kilonewton. So this is my required water, not the water content. It is my required water to raise 10% of water content. Let us go further. Here in problem it is told that void ratio will be same or constant. So I can compare initial void ratio as well as final void ratio. So void ratio is having formula Wg upon Sr. Here specific gravity of the soil will not change. So I'll put suffixes in W weight and Sr. So initially the weight was Wi, finally the weight was Wf. Initially degree of saturation was Sr initial, finally it was Srf or Sr final. So if I compare this both, the specific gravity will be gone. So W by Sr is equal to W by Sr initial and final. If I will put values from the problem, initial water content was 0.05, final water content was 0.15, and SRI and SRF I do not know. So I'll get SR final is equal to 3 times SR initial. So I know that now if I want to add water if I want to increase my water content from 5% to 15%, the degree of saturation will increase by 3 times than that of initial degree of saturation. If you have clarity about understanding of this index properties, you can solve different problems in a simpler manner. I will not take similar kind of problems in this video series, but I suggest you should practice similar kind of problems more and more from books. Let us go further to the next problem. A soil sample has a diameter of 38 mm and a height of 76 mm. Its weight is 1.15 Newton. Upon drying, the weight reduced to 0.5 Newton. Specific gravity is 2.7. In the wet state, what is the degree of saturation and water content of soil sample? Determine the void ratio and porosity. Also find out total unit weight and dry unit weight. Here I am provided height and diameter of the sample, so I can find out volume easily. So as the sample is having some diameter, it is in a cylindrical shape, and volume for that will be pi by 4 d square into h. I have the value of diameter as well as height. So volume found out will be 86149.04 into 10 raised to 9 meter cube. I have converted it into in meter cube so that unit weight and other units will be uniform throughout the problem. Now let us go solve the problem. Other things I have been provided is weight and dry weight. So from total weight I am finding bulk unit weight. Gamma B is equal to total weight upon total volume. So I have found 13.34 kilonewton per meter cube as gamma B. Now if I am having dry weight also, I can find gamma D also, so that WD upon total volume. I have WD as 0.5 Newton. I am converting it into kilonewton already, and volume I have converted it into meter cube. So gamma D comes as 5.8 kilonewton per meter cube. Now I have gamma B as well as gamma D, so I can use the formula or relationship between those. So gamma D is equal to gamma B upon 1 plus water content, and from gamma D and gamma B I can find out water content. So, putting the values in the formula, I got water content 1.3, or I can say 130%. Now I have got dry density, dry unit weight, bulk unit weight as well as water content. Going forward, I can find void ratio. Now gamma D is equal to G into gamma W upon 1 plus E. Here in this formula I have only remaining unknown is E void ratio, and from void ratio I can also find out porosity. Putting all the values in the formula, I got E void ratio as 3.57. As usual, it will be unitless. From this I can easily find out porosity by using E is equal to N upon 1 minus N formula. Let us go next. SR. For SR, I'll use void ratio again. E is equal to W into G upon SR. Here, I have only one remaining quantity is SR. I have put E value as well as W and G. I got SR as 0.9832, and in percentage SR is equal to 98.32%. Generally degree of saturation is in percentages, so I will find out and write the answer in percentage. So, dear students, you must understand all fundamental definitions as well as their formulas, because I have covered almost all derivations and formulas which are asked in exams. As GE is a totally new subject to you, you should also refer notes which will be provided soon for formulas, their interrelationships and sums. If you are still not clear with sums, formulas or anything, you should try and see the video twice or thrice, otherwise you also can ask me. So here I conclude this video. The test will be taken in next video part 5. Thank you.